Hello everyone, welcome back. Hope you're doing well and having fun working with data. In today's video, I'm going to show you how to perform two-way ANOVA test in Python. So without further ado, let's get started. I'm sure you already know what two-way ANOVA is and are familiar with the theories. It's pretty much like one-way ANOVA, but with a difference that this time we compare different levels of two categorical variables and also check if there is an interaction between these two variables. So here we have the same dataset from the previous video for one-way ANOVA. The dataset has 82 features with the target variable of sale price of the house. This time around, we are interested in two categorical variables, heating QC and season sold. Heating QC is the quality of heating resources, which has 5 levels or groups, EX, GD, TA, FA, and PO. They stand for excellent, good, average or typical, fair, and poor respectively. The second categorical variable is season sold, which doesn't exist, so we have to engineer it or simply building it out of another variable, which is month of sold. So you may say, gosh, this is already too much, but sometimes we come across this kind of stuff and have to deal with it. So bear with me. I'm sure at the end you're gonna like it. So I'm gonna show the process on Jupyter Notebook. So go ahead and open a Jupyter Notebook, import necessary libraries and packages. OLS is the one that we use for running the test. Pairwise 2-key HSD is for comparing levels of categorical variables, and Levene is for checking the homogeneity of variances, which is one of the most important assumptions for running a ANOVA test that we will get there later in this video. So for now, let's load the dataset, use head to see the features, and like previous video, we check the first assumption, which is the normality. We use QQ-plot. So you see it's skewed to right, so we're gonna make it normal, and we apply log transformation on sale price to fix it. And then we plot it again. So now you see it is around the straight line, meaning that it is normally distributed. So we're good to go for the last assumption, and it is equality of variances. We check it using Levene test. But before doing so, as I said, we need to engineer the second categorical variable or the season that house was sold. We use month of sold variable that already exists, and we're gonna build 4 levels or groups for this new variable. Let me show you the variable that we'll work with to make this goal happen. So you see MO sold, or the month that house was sold. It has been encoded from 1 to 12, each representing 1 month starting from January to December. To engineer the new feature or the new variable, which is season of the sale, we're gonna make groups. We want 4 groups: winter, spring, summer, and fall. Winter includes December, January, and February, which the numbers corresponding with these months of season are, months of the year are 12, 1, and 2, and so on. For the other seasons, we do the same. So you see, we use map function to return the results of grouping the data. And now let's see the data set. And there it is. We have a new variable called season of year that shows in which season of the year the house was sold. Mission accomplished. So let's review what we have done so far. We checked the normality assumption, then feature engineered our second categorical variable, season of the sale, and now we're going to check the equality of variances assumption for our variables. As I said, we use Levene's test to do so. First variable is heating quality, which has 5 groups, but we need to rename this variable before going to do the rest of the test, because sometimes Jupyter throw an error for spaces that are in the naming of the variable. So instead of this space, we just use an underscore and rename it to heating underscore quality. So then we compare the variances of 5 groups: fair, typical, excellent, good, and poor. And here's the result. Then we do the same test for the second variable with 4 groups of winter, spring, summer, and fall. And we run this. So you see, for both of these variables, we have p-values that are less than 0.05. So we reject the null hypothesis, meaning that variances of groups for each of these variables are not equal. But what should we do now? You see, if we had the assumption of homogeneity of variances met, we would simply move to run the two-way ANOVA test using this formula and this code. We would fit the model with sale price as y variable, season as x1, heating QS as x2, and also the interaction between these two. And then we would use Tukey test for comparisons. But now, since the assumption is not met, we're going to use an alternative method for running two-way ANOVA here, and it is called Kruskal-Wallis. We use Kruskal function from stats and put the groups that we want to test. So for heating quality variable, p-value is less than 0.05, and we reject the null hypothesis, meaning that there is a difference between the different levels of the quality of heating resources and the sale price of the house. And move on, going to the second categorical variable. We run it and we get the p-value again less than 0.05, meaning that there is also a difference in terms of seasons of the sale and the price of the house. So we're gonna find out for both variables which category is different. Since we had used Kruskal-Wallis, we cannot use Tukey test, and we're gonna use a post hoc test for Kruskal-Wallis test, which is called the Dunn test. So we need to install scikit post hocs package, then import it as SP. And now we run the Dunn test using post hoc underscore Dunn. And then we use Bonferroni correction for the p-values. And here is the result. We look for p-values less than 0.05. The adjusted p-value for the difference between group 2 and group 3 is 0.011. And also the adjusted p-value for group 2 and group 4 is 0.03. These values are less than 0.05, meaning that there is a difference between groups of 2 and 3 and 2 and 4 in terms of selling price of the house. So, as you may know, 2 represents spring, 3 represents summer, and 4 represents fall. We conclude that the seasons of the year, spring, summer, and fall, have definitely affected the price of the house. Now we move on to the second variable. For heating quality variable, we repeat the same process and run the Dunn test. From the results, we can say that there is a difference between group 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4, and finally 3 and 5. But the most significant differences are between 2 and 3, 1 and 3, and 3 and 4. 3 represents the heating quality to be excellent. It was expected that houses with excellent heating quality has different sale prices from the other groups. And now we're good to go to do the final step. In the final step, we want to know if there is an interaction between these two categorical variables, and we use the interaction plot. So here is the line chart. You see, in winter season, sale price went down for houses with poor and fair heating quality, meaning that there is an interaction between season, and heating quality. And that was it. That was the way of checking assumptions, fixing them, and running the test for two-way ANOVA when variances are not equal in Python. I hope you liked it and found it helpful. If you did, please give it a thumbs up and follow my channel. I'll see you in the next videos.